Okay, so we're basically just going to do what we just did on those graphs to a bunch of base functions. So this unit's really nice because we're just going to keep doing that same thing over and over and over again. So we're going to do it on quadratics. You guys are familiar with quadratics, right? It's just like the parabolas that we did in grade 10. We're going to do transformations on those. So just as a reminder, this is our general transformations function. I will give this to you on the test so that you can kind of have a visual of where A, K, D, and C go. You just need to know how to use them and what they do. Again, a note about the K value, when we do calculations and when we state it in words, we want to use the reciprocal of K. And we also always want to make sure the K value is common factored out from this bracket. Otherwise, we won't see the correct D value shift. So K must always be common factored out. From X and D. Otherwise, we won't see the correct left-right shift, so just make sure that you're always looking for that. It needs to be in this format where you have the brackets around X and D. If not, you common factor it out so that you can see the correct shift. So today we're going to look at transformations of the x squared function. You guys did this in your intro packages as well. You graphed the x squared function. We're going to look for vertical changes, which are changes to the y coordinates. And then we're going to look for the horizontal changes, which are the changes to the x coordinates. Remind me which values out of A, K, D, and C do changes to the y's. Alan? A, C, and how about the x's? K, D. Okay, so that's what we're looking out for. All right, so on your intro package, I had a table of values set up for you guys to graph your quadratic. And those are the points that we're actually going to use for transformations when we do quadratics. And they were basically x's from -2 to +2. So if you just remember, go from -2 to +2, it gives you each side of the quadratic. It gives you like the symmetrical sides of the quadratic. How did you guys get your y's when you had the function f at x equals x squared? What did you do in that package? Or how do I get the y's if I have these x's and I know f at x is equal to x squared? Alan? We just put them in and square them, and then we'll get the y's. So -2 squared is 4, 1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So those are our points. Order of transformations matter, so we talked about do A, and then K, and then D, and then C, and that will take care of transformations for you. Now, there's a little trick. So on your previous worksheet, you guys were doing like the stretches and compressions and flips first, and then I had you guys do the shifts last. I've got a little trick for setting up your equations so that you can do it all together, all at once, which is nice, because then you don't have to go through like a million steps of doing all of them. So here's the little trick. You are going to do, for your new table of values, you're going to do reciprocal of whatever k is times your x plus whatever your d is. And then you'll do your a value times the y, and then whatever your c value is, you add that. So what I mean by 1 over k is reciprocal of k. And then you have to also remember to switch the sign that you see in the equation. Pardon? Yeah, 1 over k just means flip it. Yeah. No, don't flip the sign. Just reciprocal, not negative reciprocal. But d, you do have to switch the sign. So this is the little trick. It will basically do bed mass for you because we will do this multiplication and this multiplication first, and then we'll do the additions after we multiply, right? So it allows us to do all the transformations of the points all together. So we're going to practice that a little bit today. And then if you still have a graph to do from your previous sheet, you can try it on your previous sheet as well. Okay, everyone have this down? We're good? Okay. One more thing that I want to practice before we do our transformations is combining the transformation equation with the parent function equation. So our parent function is x squared, and these are all the transformation equations here. I want to know what this looks like when we combine these equations together. So f at x represents the parent function x squared. So I'm actually going to just sub this in for f at x. So that means the final equation after I perform these transformations on x squared would look like this, 2x squared. That's the actual equation. Like if I wanted to go and type this into Desmos graphing calculator or something like that and have the graph of this function show up, that's what I would want to type in. Okay, this one means I want to plug this in inside of the x. So do you guys remember back from Unit 1 when I said f at 3? What did that mean? So plug it in for x, right? So replace x with 3. So that's what that would look like. So this is saying f at 2x. So it's saying replace x with 2x. So I'm going to take it. Yeah, Keith? We are actually not going to take it out and square it or anything like that. We're literally just going to plug it inside of x here. So you're going to replace x with 2x. So in this one and in this one, what's the difference between the two of these? So one has brackets, one doesn't, and that's because one is an a value and one is a k value. The k value should always be inside whatever the function is doing. The a value will be on the outside. So that's why we have the brackets on this one, because the k has to go inside whatever the function's doing, like the squared. Okay, what would this one look like if this is f at x? Alan, what do you think? Perfect. Okay, so we're just taking f at x and we're replacing it with x squared. That's what f at x is equal to. Okay, what would this one look like? When I have f at x plus 3, what is it telling me to do in f at x? Not quite. That would be if I had f at x plus 3, like on the end here, like how we just had. This one's different. It's inside the brackets like this. Liam, what do you think?
X plus 3 and squared on the outside.
Nice, yes. So x plus 3, all squared. So it means we want to replace x with this. Put it inside. So that's how we can tell the difference between a D and a C, right? D should be inside with x. C will be on the outside. Okay, what does this one look like? Yes. Brackets or no brackets? Okay, he's right. So then what would this one look like? Alan, what do you think? With brackets around the negative. So negative x squared. Good. So again, A, that's going to be outside. This one's a k. It has to be inside. Okay, so we're always going to label our final graphs with the final transformed equation with the parent function. So we're going to combine the transformation with the parent function to get a final equation for that function. Okay, we'll practice that a little bit in our examples. Okay, we just kind of practiced this, so we're going to leave this one for this lesson. We already practiced this in our first lesson again. So let's talk about the graphing things. You guys can still do that as like an exercise if you want. Okay, so here's the parent function. We're going to have f at x equals x squared. And here's the transformed function. So I want to start with my parent function points, which we talked about above, which will be 0, 0, or sorry, we'll start at -2. -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. You do not have to necessarily memorize these. You need to know that x will go from -2 to 2, and then you can always plug them in to get the y's. So I don't have to memorize all the x and y coordinates. As long as I know I start with -2 and I go down to 2, then I just square them all, and I'll get all my y coordinates for this parent function. Okay, there's a slight problem with this equation, and it has to do with something that I made a note about at the beginning of this lesson. Keith, what's the problem? You have to factor out a 2. So remember we said it has to look like this? It doesn't look like that right now. The 2 is inside, so we have to take it out first. So we're going to alter this ever so slightly. We're going to take out a 2, and then there'll be x plus 2 left in the bracket. Okay, so can somebody identify to us what do we have out of A, K, D, and C here in this transformation equation here? We have an A of what? Okay, good. Alan? K of 2. And what's the last thing that we have here? Maybe someone that hasn't answered yet. Evan? D is -2. I like that you switched the sign there too, that's good. Okay, so let's practice that little trick that I told you guys about. So the trick is this. We're going to do 1 over k times x plus d and ay plus c. That's what we talked about on the previous slide. So this means reciprocal of k. What's the reciprocal of the k value that we found? 1 over 2, so that's what you're going to have, 1 over 2. Times x, and d value? Okay, so -2. We switch the sign that we see in the equation, so it looks like +2 in the actual equation itself, but we know it's -2. How about the ay plus c? What would we have for this? So just -1 times y, or you can say -y. Do we have a c value? So just leave it then. So this is going to do everything together for us, which is really nice. So we are going to take all the x's, and we're going to plug them each in here. We're going to half them, and then we're going to subtract 2. Another way of saying multiply by a half is divide by 2. So you're going to take all your x's, divide them by 2, and then subtract 2. So let's do this quickly. -2 divided by 2, that's -1. Subtract 2. -3. -1, half of -1 is -0.5 minus 2, -2.5. Plug in 0 here, we'll get 0 minus 2, -2. Half of 1 is 0.5 minus 2, -1.5. Plug in 2 here, half of 2 is 1 minus 2, -1. Okay, and then we want to take all of our y's. And what are we doing to them? What does -y mean? Yeah, we're just flipping the signs of all of them, or in other words, we're multiplying them by a -1. So all the signs will flip. Obviously, we can't flip the sign of 0. And that will cause the vertical reflection to happen. It will flip it vertically. Okay, so we're going to graph the parent function, this starting function that we started with, and then we're going to graph what it looks like transformed. So parent function I will graph this in green. -2, +4. -1, +1. 0, 0. 1, 1. And 2, 4. And if you wanted to, this graph can also fit -3 squared and +3 squared. What are -3 squared and +3 squared? 9. So I could also add -3, 9 and +3, 9 if I wanted to. Okay, so there's the parent function. I'm going to label this as f at x equals x squared. And then transformed function. It's helpful maybe if you could do 2 colors if you have them. We'll graph each of these points. So -3, -4. -2.5, -1, that's like right here. -2, 0, right here. -1.5, -1, and -1, -4. It should still look like the same shape as what you started with. Like it should still be symmetrical on both sides. Both sides should be facing the same way. Like this one was facing up, but we flipped it down, so now they're both facing down, like that kind of idea. See how all the points are completely symmetrical with one another as well? Like these two and these two are all symmetrical. That's what this should look like in the end. Okay, somebody do the combination, like what we were practicing earlier. How do I combine this and this together? What would it look like? Basically, the trick is this. Take out this and apply whatever this function is doing onto this bracket. So if I take out the f and I apply whatever this is doing onto this bracket, what does it look like? So I'm going to rewrite this without this. Negative, and then we have 2x plus 2. And what is the main operation of this parent function? What is it doing? There's only one thing that this parent function is doing. What's the operation? It's not a trick question. It's right there. What is this? X what? What's the main operation that is happening right here? So squaring. So we're going to take that operation, which is squared, and we're just going to put that onto the bracket. So I'm going to put squared there. That's it. That's the equation. Drop this f, because the f represents the parent function, or f at x represents the parent function, and then apply the operation onto the bracket. That's all you have to do. So that's what our final equation should look like there. Okay, let's try one more with this new technique that we have. Maddie? Like this? Let me know when you're ready. Okay, I want you guys to see if you can set up the transformation equations for the next one while we're waiting up here. So same parent function, same parent points that we're starting with. And then tell me, see if you can figure out a, k, d, c, and create those 2 equations. Good? Okay, so we're going to start with f at x equals x squared, same x and y coordinates. And I want to know, what do the tops of these look like? So it might be helpful to list a, k, d, c before you start. So who can tell me AKDC? Keith? Mm-hmm. Mm-hmm. Very good. Perfect. Okay. Did anybody get one of these two equations here from these? 1 over kx plus d, so reciprocal of k times x plus d. What would that look like? Sam? Or just negative 1/3 x, that's fine. Yes? Minus? Minus 1, yeah. Okay, that's what it should be. Reciprocal of the k, so reciprocal of 3 is, or negative 3 is negative 1/3. Use the opposite sign of d, which we already did. And then the a and the y, or the a and the c will look exactly the same. So negative 2 and negative 1. Okay, so we're going to divide all of the x's by negative 3. And we're going to subtract 3. So I'm going to do this quick. You guys can help me. Everyone grab your calculators so that we can do this quickly. Everyone choose one to calculate. We'll all do it together. So negative 1/3 times negative 2 minus 3. So this one should give you negative 2.3. Okay, then you do negative 1. Okay, I'm going to let you guys calculate. At least choose one to calculate. One out of the list that's left. And then we'll see if we get the same answers. That's fine. Did you get the same thing? Yeah. Anyone do the negative 1? Liam? Good. Ends up being like negative 2.666. So we'll say negative 2.7. We'll round it. How about the 0? Anyone do that one? It's just negative 3. It makes, that will be 0, and then we'll have minus 3, so negative 3. 1? Very good. And did anyone do 2? Evan? So it's 6.6, so we'll round it up to 3.7. Okay, y's, let's take all of these y's. We're going to multiply them by negative 2 and subtract 1. So everyone take 1 to try in there. And once I've done 4, this one's also done. So I don't have to do it twice because there's 2 4s. They should give me the same answer. So I'm not going to do that one twice. Or the 1s as well. So what do we get for 4 in here?
Negative 1.
Yep. So I'm going to plug that in for both of the 4s. Anyone do 1? Yes, you should get negative 3. And how about 0?
Negative 1.
Just negative 1. Okay, good. Okay, we're going to graph the parent function. Same points as last time. I'll add the negative 3, 9 and the positive 3, 9 here as well. Whenever we have more than one graph on, or one function on a graph, we'll label them just so that the reader knows which is which. So I'm always going to be labeling these like as the parent function equation and then the final equation as well. Okay, and then let's graph the new function. So negative 2.3, negative 9. That's about here-ish. This one's going to be kind of skinny. Negative 2.7, negative 3. -3, -1, that's here. It's going to be very squished. -3.3, -3, it's about here. And then -3.7, -9, about here. Oh, no, sorry, it's about here. So very tiny because we did a horizontal compression and also a vertical stretch. So it really kind of like made our graph extra small here. Okay, again, it still looks symmetrical. It still has that general U shape, so that's good. What does our final equation look like here when we combine into one? G at x I'm just going to do it up here. So the trick is just drop this out and apply the operation onto the bracket. So somebody tell me what this looks like as a final equation. Liam?
Bracket, -3, bracket, x plus 3, bracket, and square times 1.
Yes. But -2 in the front. Yeah. Perfect. So drop the f part out and then put the squared onto the bracket. That's all you have to do. Okay, so this is exactly what I would expect to see on like a test or a quiz and on your homework questions as well. You have the parent function, you have it labeled, you have the final equation, you have it labeled, and then you have some evidence of like what points you started with and how you transform them. So I want to see, I want to see some evidence of how you calculated your points. I don't need to see every single step, like every single transformation, as long as I can see like what calculations you did and how you got your new points. Okay, so that would be what I would expect. I'll zoom out a little bit here in case you're still copying this question. Okay, so we have 20 minutes. Let's try to finish what we can from, like if you're already done the first worksheet, let's try to finish what we can from the second one. I might actually just, let me see here from the workbook. Okay, I would like you to try at least 2 of these. So let's say B and D from number 1 at minimum. And then see what you can do with number 2. See if you can create the equation given the list of transformations. That's kind of opposite. It's really not like number 2 takes like 2 seconds to do. So we'll try 1, B, D, and 2. See what you guys can get done today. I don't want to give homework over the break, so let's see what we can get done in class, and then we'll reassess at the end of class, okay?